Hello, welcome. Today I wanted to take a look at what OWASP states is the #1 security vulnerability in APIs, that is Insecure Direct Object Reference, otherwise known as IDOR. This is a super common vulnerability and it occurs when proper access controls aren't put on objects, and that allows unauthorized users to access or edit information where they shouldn't be able to. So I'll start today with a basic demonstration of the vulnerability in action, and then I'll take a look into the code. Then I'll share some high profile and well-known examples where this vulnerability has led to some major breaches. And finally, I'll share some resources for defenders and the key methods for mitigating this risk. So for the demonstration today, I wanted to show how a IDOR vulnerability can lead to information disclosure. The example we've got here is a file upload or hosting platform where we can upload files and view it, and there's a whole bunch of functionality. So I'll just show some of the basic features. We can upload a test file, only accepts text MIME types, and we'll set it as public, and we can upload the file. If I view the file, the first thing that sticks out to me about this page is that the number up the top here looks like just a simple file identifier, and that makes me think that if I searched for other document numbers, I might be able to find other files and display their contents. In order to test this, I'm going to use some automation. So the first thing I'm going to do is capture the request in my proxy, and I will save this to a file. I'll just call it getFile.request, save that, and I'm just going to edit the request and put in, this is where I would like to automatically search, let's say for numbers 1 to 100, so I put in the fuzz parameter there, and I'm going to use a tool called fuzzfasterufull, FFUS, and I give it the request file, the request protocol, because otherwise it defaults to HTTPS. The word list I'm using is a sequence of numbers 1 through 500, and I will MC as match code, so it's matching on all status code responses. If I send that, I can see that almost all responses are coming back with a size of 82. So I'll filter that so that I'm only picking out responses that are unusual. And we've got a list, so it looks like that's the file I've uploaded, and that's 5097 in length. Looks like there's another large file here, which is 100. So if I go back and view 100, I'll turn off my proxy. There we go. And it looks like this is probably intended to be a publicly viewable document, given it's the welcome. So let's have a look at one of the other ones. Let's see 99, for example. And immediately we get an unauthorized response. So this probably indicates that the developers foreseen this issue and they've got some access control over documents to prevent IDOR, at least on this endpoint. However, there is another endpoint that seems to have slipped through the cracks in this application. So if I show my files, there's an ability here to block or reserve a file. And this endpoint can also be used to view, if I go back to that 99, I'm presented with the details of another user's file, James Mason's file. I can view the contents of that file, and I can see the group. So this is obviously a lapse in the access controls that they've put on the endpoints. And you can see that this could scale to be a fairly significant information disclosure. So that's the basic premise of a IDOR, indirect insecure direct object reference. I'm directly able to reference another object that I shouldn't be able to reference. So let's jump into the code and have a look at the anatomy of what went wrong here. Firstly, I just wanted to point out that the static code analysis, it has picked up a number of issues, hard-coded secrets, directory traversals, some code quality issues, etc. But it hasn't picked up the IDOR vulnerability. And similarly with mass assignment vulnerabilities, this is classed as a business logic vulnerability. And so it's pretty difficult for a static scanner to be able to identify these sort of issues. It may show up in a dynamic analysis, but often that sort of testing is done a lot later in the development cycle, or in some cases not at all. So I just wanted to demonstrate that it isn't found by that. So jumping into the actual code, the developer has actually implemented some access control for the endpoints, and I'll quickly walk through how it's meant to work. In the middleware, there is a authorities, and this is checking authorization. You can see that it is checking whether the path that's being referenced is in these different lists, either file owner required, group membership required, or group owner required. And then it's performing the relevant check before it will actually redirect to the function or endpoint. These lists are defined in the settings. So we can see that if we scroll down, we have a list of endpoints that require authentication. That's pretty much all of them. We have file group membership required. Note that get file detail is included here, but there isn't the block endpoint, and that's the crux of the issue here. And we've got the group membership required and file ownership, etc. Outside of the middleware protections, there's also logic built into the function itself and the way that it's displayed. So if we look at views on get file detail as an example, we can see that it's also performing a check about whether the object group, so what group owns that object or that file. It's checking whether the member making the request, the user making the request, is a member of that group. If it is, then it's setting this variable level to 1, and if it's not, it's leaving it at 0, and then it goes on to get the file contents. This level variable is used then in the templates, where we can see the get file detail template. This is how the information's rendered. This makes use of the level to determine what features are displayed. So, the ability to edit a content, and that button is displayed if you are level 1. Otherwise, you might just be able to view that content, for example. And so that's another layer of logic in the application that's meant to control access to these endpoints. So just to sort of sum that up, I'll step through how this works for the get file URL. So firstly, this middleware will check. It knows we're going to the get file detail endpoint. So authentication is required and group membership is required. It will perform those checks, authentication and group membership. Provided that passes, it will then call the get file detail function, That will set my level variable and fetch the file contents. And then we have the template, which will render all of that information and present me with the options depending on my level of authorization. So that concludes the demonstration, and for the rest of the video I just wanted to share some resources and discuss the potential impacts and examples. So to begin with, I wanted to share some recent or notable examples of where IDOR vulnerabilities have led to major breaches. So I'll start with a very recent example, which was in a product that's pretty widely used, and that is Microsoft Teams. So this vulnerability was disclosed on June of 2023, and at the time of recording this video, it's still being actively exploited in phishing campaigns. So Microsoft Teams by default allows messaging between tenancies, and so that means people from different organizations, if they have one another's addresses, should be able to message each other, and the message is flagged as an external entity. What isn't supposed to be allowed is file sharing from external entities, and that's to help avoid phishing and sending of potentially malicious files. And the IDOR vulnerability is one that allows users to get around this security control. And we can see here by exploiting an insecure direct object reference, they're able to manipulate the recipient ID in a post request and deliver a payload directly to the target's inbox. So that's an example of IDOR being used to send malicious files to end users, and we can see that this is being actively used. There's a advanced persistent threat actor listed there that is using this to deliver phishing lures. Another notable example in the Australian context is the Optus API hack. So the details of this one haven't been confirmed by Optus, but during the Optus hack, the hacker leaked source code onto GitHub and made some claims about the way the hack took place. And one of the things that they claimed was that there was an API that did not have appropriate access controls, the one listed here, and he was able to brute force the customer number and thereby dumping a huge amount of sensitive information about Optus customers. Now, just to mention that Optus at no point confirmed that that was the case, and this API was very quickly taken offline, so there isn't really any way to confirm that. Moving on to a final example, and this one is this is an example of a very large breach caused by an IDOR. On this page, talking about the largest breaches in US history. The third one is the First America Corporation, and this was an example where 885 million file records were leaked due to a insecure direct object reference. The exact specification of how that came about or what the endpoint looked like, I wasn't able to find, but suffice it to say, this is the sort of worst case scenario of how this sort of vulnerability can be used to perform damage. And to wrap up this video, I wanted to share some resources for defenders on how to remediate this vulnerability. I'll start by sharing the information from the OWASP API Top 10. This falls under broken object level authorization, and it is the #1 risk in APIs according to OWASP. As we can see, it's widespread prevalence, very easy to exploit, and there's some information here with different scenarios and some high level information on prevention. They also have a authorization cheat sheet which provides some additional information for developers and engineers, and there is also a specific cheat sheet for IDOR, which covers more specific mitigations. Another great resource is from the Australian Cyber Security Centre, who released an advisory recently in July 2023 around preventing web application access control abuse. There's a list of details there about how it can be manipulated and some of the damage, the impact, and some very specific guidance around mitigations, including secure coding practices, etc. To summarize the mitigations, the OWASP sheet actually probably does the simplest way. There are two main strategies for mitigating this. The first indirect way is to use complex identifiers for objects in your application, and this will make it really difficult to brute force or guess what another object is. So even if you would be able to reference another object, you would never be able to guess the particular thing, and you can use sufficient randomness and a large enough identifier, then that can be effective. However, this should also be paired with access control checks on any object that users try and access, and we demonstrated what that looked like in the example in the demonstration. Okay, that's all I wanted to run through today. Hopefully you enjoyed. If you have any questions or suggestions, please don't hesitate to contact me, and I look forward to seeing you in the next one. Thanks very much.